Hello everyone, thank you very much for joining me on the webinar this afternoon. We'll be going through the Cybersecurity Lifecycle and exSILentia Cyber. Here's a quick abstract of the webinar that will be sent out with the slides to kind of provide an overall summary. If you are having trouble with audio, you can always use the questions tool or ask questions as we go throughout the presentation. We have administrators online who will help to make sure any questions get answered. And then for the technical questions, I'll either stop and answer them as they come up, or we should have about 10 minutes at the end to go through all of those questions that we haven't answered. Before speaking about our topic for the webinar today, I'd like to just do a quick introduction about myself. My name is Patrick O'Brien, and I'm a safety and cybersecurity engineer at exida. My background was in chemical engineering at Penn State, and so I started out more so in the safety role, doing process hazard analysis, lots of risk assessments. And then over time, as cybersecurity became more and more important for that, I kind of naturally transitioned to a role that looks at both safety and cyber. And so I've been doing that for the last couple of years now. At exida, we're a customer-focused company, and we really work with our customers to achieve safe, reliable, and secure solutions. And there are three main ways that we do that. The first is our enterprise tools. So thinking about exSLentia, exSLentia Cyber, we also have a number of OEM tools now, such as ArcX or FemitaX. And so these really ensure technically correct results. And then they also help to get to those results more efficiently, which can have a lot of benefits in the process. And so we'll look a little bit more at that piece today when we look at the cybersecurity lifecycle and how exSLentia Cyber fits in. We also offer certification services. We're the world leader in functional safety and industrial control system certification, as well as a suite of lifecycle services to try to tackle the really toughest problems implementing functional safety and cybersecurity. When it comes to achieving practical cybersecurity, there are a lot of different ways that exida can help, everything from consulting services to certification, as well as training courses, tools, and reference material. And the slides that we send out to go with the webinar, there'll be a little bit more background information on some of those pieces. Today in this webinar, we're really going to focus on the cybersecurity lifecycle, trying to understand, why is a lifecycle approach necessary, and what sort of benefits can we hope to achieve from a lifecycle approach. Next, we'll look at exSLentia Cyber and try to understand where this fits in with the lifecycle. And lastly, we'll look at what sort of benefits are there to a tool-based implementation. Before we look at the cybersecurity lifecycle, I want to just take a little bit of time to go through a practical example and think about why is it that a lifecycle approach is necessary. If we think about the NotPetya attack, this was a nation-state wiper worm. And so for a wiper worm, this is, if we kind of think about, a ransomware attack where the attackers encrypt and lock the data on hard drives and other devices, and then if a payment's made, they can then give this data back. A wiper worm actually just deletes all of this data from the start. And so this attack was believed to be developed by Russia to specifically target the Ukraine. And so the Lenkos group was an organization in Ukraine, and it looks like the attack was first installed on their update server through a backdoor that had been found in the system. What made the NotPetya attack kind of so important to look at was it actually paired two very powerful tools in actually developing the wiper worm. So the first one was Eternal Blue, which was the way that the worm was actually able to self-replicate, as well as Mimikatz, which pulls passwords out of stored memory. And so the Eternal Blue was a vulnerability in outdated Windows systems that allowed it to spread very quickly through those. And then what happened is once it got anywhere onto a network, if there are any unpatched systems, the Mimikatz would then pull the passwords to the patched system. So it wasn't just unpatched systems that were susceptible, as soon as it got onto the network, it could also impact the recently updated or recently patched systems. And that's why it was able to spread worldwide so quickly. Tim Bossert, one of the Homeland Security advisors at the time, described the cyber attack as the equivalent of using a nuclear bomb to achieve a small tactical victory. Due to kind of the widespread impact and the fact that such a devastating attack had been used for something that was really a small objective that it seemed was trying to be achieved. If we look at the real cost of the NotPetya attack, it hurt a lot of industrial control systems as well as other types of automation systems very hard. If we look at Merck, the pharmaceutical company, it's estimated that the cost was around $870 million. And then we can see, FedEx TNT, so looking at delivery, we've got construction for Saint-Gobain, shipping for Maersk, some food and beverage as well as consumer goods, lots of different either, if we think about it, manufacturing or other types of automation systems were really hit hard by this attack. And the total cost, considering these companies that had a lot of damage as well as companies with less extensive damages, is expected to be at $10 billion. And so the original attack happened back in 2018, but it's also recently popped up in the headlines again because insurance companies and regulators are trying to define whether or not this attack accounts as a type of cybersecurity warfare, because that has very significant implications on what sort of insurance payouts are required and how much of that falls to the companies that have been impacted. And so that will definitely be something to keep an eye on because it may be relevant to other cyber attacks that we see in the future. The real takeaway from this, though, is we don't want to look at this NotPetya attack as a once in every 100 years, once in every 1,000 years, maybe not even a once in every 10 years type attack, because we see that cybersecurity threats are a real and present risk to operations. A study by the Kaspersky Group showed that between 2016 and 2017, it was expected that over half of all industrial control systems reviewed had experienced a cyber incident. And of these, some of them experienced more than 10 attempted attacks in that time frame. And so that goes to show just how prevalent these numbers of attacks are. And it's expected that this will probably only continue to grow as more and more attackers continue to develop tools, how even unskilled attackers have access to potentially some very sophisticated cybersecurity vulnerability exploits. Another more recent study done in 2018 looked at manufacturers in the United Kingdom and saw that 48% had experienced an attack in the last year. So right around that 50% mark. And what they saw was of those manufacturers that were attacked, half of those attacks resulted in business loss. So about 24% of manufacturers had a business loss due to a cyber attack. And it just goes to show that right now, a lot of organizations are being targeted to attack. And right now, as high as 50% of those attacks may be successful in causing damage. And that really just emphasizes how at risk industrial control systems are. If we think about it, really the question that we want to be asking and then answering is, how can organizations be better protected from cybersecurity threats? Is it an issue of just improving awareness? Are all of these attacks due to poor cyber hygiene, clicking on suspicious links, posting passwords, reusing passwords? Is it something simple where we can fix it with just human behavior? Is it something where maybe the big picture is just not being seen, and so there are these critical security risks, but they're not being flagged and addressed in time? Does it have to do with the technology selection? Are there specific solutions that are out there that if everyone implemented them, we wouldn't be seeing any more of these attacks? Is it, related to maintaining security over time? Are there patches that aren't being deployed, or just seeing outdated systems? And when we look at it, I mean, these are all good questions to ask when thinking about one's cybersecurity posture, and they all play a role. But not one of them is a single answer. There's no single step that can be taken that really, reaches a level of security and allows you to stay there over the life of an operating facility. And so that's why we really want to consider a life cycle approach. An effective life cycle approach will tackle all of these elements. It's got to be clearly communicated to the organization. You've got to have those cyber refresher training to make sure that the human elements aren't that weak link. You've got to look at the risk assessments, making sure that those cyber critical assets are identified and that sufficient protection is put in place for them. Technology selection is certainly a big part of it. So looking at what sort of security capabilities are necessary, as well as understanding, technical currency. Is something going to be outdated very quickly? That all plays an important role. But something I do want to stress is sometimes organizations feel like if they just, make a systems upgrade or go to this, newest piece of software or, hardware, that the human elements don't matter. And while the technology selection is obviously a very important part of achieving cybersecurity, forgetting the human element, not maintaining the security over time, and not necessarily doing that risk-based approach, you really have no way of guaranteeing security. And so it's really important that all of those elements are looked at together. And so really what we've seen and what the industry is moving towards as the most effective way to implement that is the cybersecurity lifecycle. So when you think about what sort of international standards, what guidance is there for industrial control systems, IEC 62443 really is becoming the governing document for that. And it can be a little intimidating to look at first because it does comprise 14 different components, and some of these components are related to end users, where some are really just looking at equipment manufacturers or integrators. So there's definitely a lot to do to kind of break down what specific requirements of the standard should be considered for each party and how that fits in together for the overall life cycle. But in section 6, 24431-1, this is in the general kind of overall requirements. In the concepts and models, this is where that idea of a cybersecurity lifecycle is outlined. And there are specific steps that can really be thought across, whether it is the end user, the integrator, or the manufacturer, that really do lead to improved security and help to tackle those key security milestones. And so when we take a little bit of a closer look at this life cycle, we can see that there are 3 main phases. The first phase is the assessment and maintenance phase, or is the assessment or analysis phase. And so this is where you scope the system that's going to be reviewed, you identify what the critical assets are for cybersecurity. You can go through and then take the network architecture to establish a zone and conduit diagram. And so this is really where the first step of risk assessment is completed. And so by doing that high-level risk assessment, you have an outcome of all of those critical assets that need to be evaluated further, as well as transforming the initial network architecture into that zone and conduit diagram with boundary devices such as firewalls or managed switches to segment the network into similar security requirements. This is also where the initial security level target is defined. If you're familiar with functional safety, we'll be kind of pointing to parallels at different points throughout the presentation, but this can really be thought of as your safety integrity level, or the requirement for achieving a given level of security. And so this is initially identified here in the high-level risk assessment to then go through the rest of the life cycle. The next step is for each of those zones that we've now segmented off, to go through and analyze the security risk for each of those zones. And that's done during the detailed risk assessment. Vulnerabilities also come into play here. So a vulnerability assessment is typically performed as part of this phase and then fed into the detailed risk assessment. From here, a security requirement specification or a CSRS, kind of similar to the safety requirement specification, is made. And this is where the formal requirement for the security level is determined for each zone. And any additional security capabilities that must explicitly be met are included here to ensure that when the specification is carried out, that all of those necessary concerns are met. And that really is what feeds into the implementation phase, where the cybersecurity countermeasures are applied to make sure that there's enough protection there. And that validation to show that sufficient countermeasures are in place to show that everything meets the tolerable level of risk is going to be the validation of the design or the security level verification. And so this is either a qualitative review of the capabilities or a semi-quantitative review of the overall likelihood of a successful attack to demonstrate that the acceptable risk targets have been met. Once the design has been validated to show that it will provide adequate protection, the implementation phase then goes to the construction and then the verification activities, such as the Cyber FAT and Cyber SAT, where really those countermeasures are tested and verified to be working prior to operation before any hazards are introduced to the system. And so that Cyber FAT represents a really good opportunity to do penetration testing before the system's connected and there's an opportunity for potentially damaging the running or live system. Depending on when the SAT is conducted, that can also be kind of the last opportunity for penetration testing. But if it's already kind of being fit into a already operational system, there's sometimes not the best idea to do that penetration testing if it could impact the currently running network. So once the system is put into place, it then falls into the third and final phase, the maintenance phase. And so although a lot of times efforts spent to hone in on the assessment phase and the implementation phase, the facility, the industrial control system, is really going to spend most of its life in the maintenance phase. And so it's very important that the considerations for security are maintained over time and that kind of the necessary steps to maintain that level are completed. And so during the maintenance phase, what's looked at a lot of times would be patch management and antivirus management to make sure that there's up-to-date protection on individual devices. Things like monitoring the security, so intrusion detection systems, as well as security event and incident monitoring, making sure that the system is not being currently breached, or if there does seem to be some sort of security concern, that can be quickly investigated and corrected, or whatever actions need to be taken are put in place. From there, we can look at the modification and decommissioning. So this is really understanding what impact changes on the network will have and trying to ensure that none of the changes made over time result in an increased security risk. Part of this then is also looking at the periodic assessments. So revalidation of the vulnerability assessment as well as revalidation of the cybersecurity risk assessment to make sure that the risks, as the threats evolve over time, as technology changes, to make sure that the system is still meeting the tolerable risk requirements and that there's not a significant gap that needs to be looked at for some sort of strategy of mitigation. And so when we look at the life cycle, kind of each of these highlighted areas, so for our risk assessment, both high level and detailed, as well as the security level verification, the exSLentia Cyber tool is specifically designed for completing those tasks and providing all the necessary documentation to comply with IEC 62443. In addition to that, it can also be very useful in the maintenance phase when it comes to reviewing the impact of modifications and also looking at the periodic assessments to revalidate the risk assessment. It kind of keeps all that information in one place and gives you an effective tool to go through and carry out that revalidation. In our next section, we'll talk a little bit more about what the exSLentia Cyber tool is, and really how you can use it to complete those lifecycle tasks that we've looked at so far. So exSLentia Cyber is split into two modules. The first is CyberFacts, and so this is a tool for completing high-level risk assessment and detailed cybersecurity risk assessment. It's modeled based off of a HAZOP methodology, but then customized for the concerns and considerations for cybersecurity. So instead of following the guide words to look at deviations and the potential consequences, there are actually threat vector guide words that are used to look at threats or specific threat agents and understand how, based on their skill level, they can impact the control system and lead to different consequences. And so we'll look at an example worksheet and talk through why that is an effective method for going through and reviewing the cyber concerns. On the security level verification side, that's done in the CyberSL module. And so this supports both a semi-quantitative approach that you can think of kind of similar to a CyberLOPA, as well as a qualitative approach, which is based off of the capability requirements in IEC 62443 section 3-3. And so we can talk about a little bit more of those two different methods of completing the analysis. So for the cyber risk assessment, when we think about the high-level risk assessment, the key here is really to review either the zone and conduit diagram if an initial one is put together, or to look at the network architecture and identify what needs to be segmented to fit into a zone and conduit diagram. The goal is to identify the areas of highest risk and really come up with that definition for what the cyber critical assets are. And as part of this assessment, you're only looking at the consequence, assuming that the likelihood of a compromise is 1. And the reason for this is it helps the high-level risk assessment to the activity to go quicker, and then allows you to really hone in on what sort of devices will have an actual impact. If we look at the enterprise workstation and think about if that is compromised, maybe we only see a denial of service for a single user, so they're not able to see certain process information from a remote location, or they're not able to fill out a certain report. It certainly has some impact, but it's not really leading to an impact on operations or some sort of business interruption. But if we talk about the engineering workstation for the basic process control system or the PLC there, now we talk about a compromise that could be modifying the operation of the plant. Valves could be moving, set points could be changed. There's the potential for a real world consequence and significant damage or even some sort of safety concern. So that's something that we would look at as potentially having a higher consequence that we need to look at more in depth. And so part of that activity of going through and identifying those concerns is to define the initial security level target, and that will then kind of feed forward to the rest of the lifecycle tasks and to prioritize solutions. And so in exSLentia Cyber, we've got all of the steps for documenting those threats, documenting that the likelihood is considered to be 1, and then defining the consequence based off of an organization's risk matrix. And so that can be done to automatically populate what the initial security level target is going to be. Once the high-level risk assessment is completed, then we can look at the detailed risk assessment, where we're now, for those cyber critical zones, we're really quantifying the cybersecurity risk to get a better understanding of if additional countermeasures are needed or not. This is also where then that information from the vulnerability assessment comes in and provides a key input into that worksheet. If we look at it and think about in this example system, we identified that the basic process control system could have significant impacts if it's compromised. If we think about it, the safety PLC and the SIS engineering workstation, that represents another area where if there's modification there, we could see real-world impacts, we could see safety concerns. And so that's something else that we're going to flag to review as a higher consequence in our detailed risk assessment. Here now, we're modeling what the threat vectors to get a better understanding of both the likelihood and the consequence. And so in the latest draft for IEC 62443 section 3-2, this is the part that really looks at how to follow a risk-based approach and how to do a risk-based analysis of the industrial control system. It's updated the language to say that now likelihood may be looked at and consequence must be looked at. Originally in the detailed risk assessment, both likelihood and consequence were required steps. What's changed though is kind of a reflection of one of the main debates going on in the cybersecurity community, and that's whether or not the likelihood of an attack can be really quantified or estimated with any level of accuracy. The one approach is to say that cyber attacks are ever present, that there are significant likelihood for attack out there, and trying to reduce the likelihood doesn't necessarily provide value for the time you're spending to try to figure it out. And it's really better to model it just as a consequence-based risk to really try to understand what the most critical assets are. The other approach says if you just assume a likelihood of 1 for every attack, you're potentially overestimating and over-designing for some attacks that could be agreed to be less likely than others in industry. And so on risk assessments that I've worked on, I've typically found it to be helpful to try to at least have some sort of baseline for the likelihood and understand what types of attacks are more likely than others, while taking into consideration target attractiveness and other modifiers like that that would change the relative likelihoods. And so that's something that is supported but not required by the standard, but definitely would recommend considering when doing that detailed risk assessment. The exSILentia cyber tool is actually configured so that it can support either approach that is supported by IEC 62443. So the security levels and the risk can either be solely a basis of the consequence, or it can be determined for both consequence and likelihood. So the tool gives you the flexibility to make the decision on how your organization wants to implement it. After the risk is determined by looking at the likelihood and consequence, so exSILentia will automatically calculate that, there's the ability to take credit for existing or planned countermeasures. So whether they're things such as firewalls to prevent external network connections, or the up-to-date patching or antivirus on the system, some sort of human action, so whether it's a periodic review of the access logs or a review of the configuration, there are a lot of different steps that can be looked at as potential countermeasures. And so those can also be considered in the worksheet. If we look here at an example of the CyberFacts worksheet, we can see that there are 3 main areas that we will define and then kind of work through when going 3 main different levels that we'll look at and then define the specific threats and consequences within. The highest level is the overall zone. So we can think about for each zone in our zone and conduit diagram, we will define that. So for example, we could be looking at our BPCS zone, we could be looking at our SIS zone. Within that, we look at cyber nodes, and we can think of each of those nodes as an individual device or a connection that needs to be looked at and reviewed. And then the threat vectors are really how we can group types of threats that we want to look at. And so this can be fully customized, but the 2 main approaches that we're seeing are either looking at threat vector categories, so things like threat vector domains, whether they're, social engineering would be an example of one. We could talk about what sort of threats would we consider as physical security, what sort of impact or threats we see with communication, hardware, software, thinking of them as kind of big groupings where we could group types of, vulnerabilities, types of exploits that attackers might use. Another method is to do it by type of threat. So looking at threat agents. So what sort of consequences could a nation state type attacker execute? What could an maybe unskilled but more frequent type of attack cause? So there are a lot of different ways that you can customize the worksheet to really specialize in what the system and what the risk assessment is reviewing. So once kind of the architecture is defined, then you can move through and for each device, identify what threats are seen as a concern. The likelihood can be documented. And then for each of those threats, an understanding of one or more consequences can be defined based on what impact that will have on continued operations, what sort of business interruption it will have, and you can define the category, whether it's some sort of business impact or a safety related impact. And so based off of that consequence severity, then the risk is determined by the tool. And so if we think about using it to complete a high level risk assessment, the steps would be very much the same. For likelihood, we would just select the highest level of likelihood because that's not something that's being considered yet in the high level risk assessment. And then once we've identified the severity, that will tell us what the most critical devices are just based off of that consequence giving us our risk. For the detailed risk assessment, we kind of look at that as a starting point with a little bit of a deeper dive on the threat likelihood. And then we can come into the countermeasure area and consider what countermeasures would apply and provide some more information to determine whether or not we can credit those. If we do see that there are effective countermeasures, we can then reduce the likelihood of a successful attack, and that's then where the reduction in risk occurs for having a lower likelihood of attack, where we can capture that the risk has been reduced. We've got the capability within exSILentia to link countermeasures. So once a countermeasure is defined once for a project, it can be easily linked to any other threat or consequence scenarios. Additionally, a lot of organizations we're seeing define a generic list of countermeasures that they consider to be effective. And so that can be pre-populated before the risk assessment is began. And then for any scenario where that countermeasure is determined to be used or it's determined to be effective, it can then be automatically linked to show up in that area. In addition to this, we also have the capability to define recommendations within the tool. So if we see that we don't have enough current countermeasures and we know that more need to be implemented, we can then define that and easily link that to each scenario where it applies, and that will pull in the risk ranking to help with the decision of whether or not that recommendation is necessary to meet a LARP. So that provides a quick overview of what we could look at in the CyberFacts tool. In the CyberSL module, this is now where we're completing the security level verification. And so a key thing to look at here is that we can automatically transfer all of the data from the CyberFacts module to the CyberSL module. So all of the threats, consequences, consequence rankings, and countermeasures that we define during the risk assessment can get automatically pulled over to that security level verification. And this allows us to review our design countermeasures and ensure that we're bringing the risk for that zone to a low enough level. And there are a couple of different factors that we can also look at here. So target attractiveness can be looked at as a modifier here to see how much that will increase the likelihood of an attack for an organization. We can look at the kill chain relevance or other types of cybersecurity models to see if, due to the number of devices that would need to be compromised or the pathway that the attack would need to take, if the likelihood is either, say, more or less than before. And so that would be how we can go through and do a semi-quantitative type approach for SL verification. Alternatively, it can be done qualitatively and just used as a means for documenting that the security capabilities are met to show if there are any gaps and make sure that the sufficient requirements are met for that approach. If we look at the CyberSL module, anyone familiar with the LOPEX module in exSLentia can see that it does have a similar framework. The main differences here are, connecting it to the Cyber PHA module instead of the LOPE being connected to the PHA, as well as some unique categories that we can define, including target attractiveness, that is a modifier greater than 1 that we look at. For the conditional modifiers, we can also look at things that we would look at in a traditional semi-quantitative approach. So things like if we've got some sort of release with a potential ignition, we don't need to assume that this will ignite 100% of the time. We can actually look at, based on the size of the release and the type of release, we may be able to define some frequency at which that fire event is expected. For our countermeasures, we can define and determine whether or not they're applicable to a given scenario. So if we think about some of the cybersecurity countermeasures we talked about before, such as the firewall, if our cause was some sort of external agent, gaining access to the system and trying to establish unauthorized access, then we could certainly look at the firewall as an effective measure. If we're thinking about some sort of unintentional incident where it's an insider or some sort of contractor connects an infected device, then we could see that while the firewall may not be protecting, any sort of physical security barrier would be effective there. And so this allows us to define which specific threats a countermeasure will protect against. And so for each threat, the current mitigated likelihood of a successful attack can be calculated out on the side, and this helps us to identify what is really driving our cyber risk currently. And so if we still have, to get to our tolerable risk, say we still had a risk reduction factor of 100, and we look at it and most of the likelihoods have been brought down all the way to 10 to the minus 7 or so. But we see there's one threat that's still at, 0.1 or some sort of 1 in 10 years. We can really focus in on, say, this type of attack, whether it's in person, whether it's some sort of knowledgeable outsider, we could say that this is what we're not currently fully protected against. Let's think about what cybersecurity countermeasures would be specific to protect against this concern. And that can really make identifying what sort of additional countermeasures are needed much easier. Similarly, if you use it for the qualitative approach, it can provide a visual documentation of here are the requirements that are currently met. Here's where we've got a lot of gaps. Let's look at what can we do to start meeting those gaps. So now that we've done a little bit of an overview of how the CyberFacts and CyberSL modules work for completing risk assessment and SL verification, we're going to kind of walk through quickly the benefits of a tool-based approach. The first benefit of a tool-based approach is really institutionalizing corporate knowledge. And so really allowing for that knowledge capture to make sure that what's done one place in the organization can be replicated elsewhere, to ensure that for those very knowledgeable personnel who are kind of documenting the cybersecurity policy, making sure that's easily accessible and can be accessed by other people in the organization. And so embedded databases provide access to traceable data within the tool, both user-defined and also industry-based data. There's a library for easy information sharing, both within projects and to different projects, as well as user-defined project configuration. So things like a customized threat vector list, a customized list of countermeasures that are considered. All of that can be documented and put together for the organization so that they've got a really clear template that's easy to use to go through and complete these evaluations, as well as predefined reports so that once the analysis has been completed, that it's easy to go forward and share that information across the organization. The knowledge capture also plays a role in the data core features. And this is really, I like to think about them as the little elves working behind the scene in exSlLentia, but all of the coding that goes into it to allow for data to be transferred from module to module, provide the linking of data, and provide you access to those event frequency and industry databases. On the safety side, there is really a prevalent amount of information both on initiating events and protection layers, as well as then when you get to the phase of doing the SIL verification, so the safety integrity level verification. There are a lot of failure rate databases such as the SERH that really give a good understanding of what that data is. For cybersecurity, a lot of that industrial data is still developing, but there is some best practice, some starting points that can be provided and that are included in the tool to help with the decisions that are made during the analysis. Additionally, the user inputs are stored in the enhanced libraries, and so they're available for quick reference or for use on new projects. And so some of the things that can specifically be done with exSlLentia Cyber would be the threats, the threat vectors, countermeasures, cyber event scenarios. If there are generic recommendations that can be referenced coming from some sort of organizational cybersecurity standard, any of that can be customized and repeated throughout the tool so that whoever starts from that base configuration will already have access to it. That is also true of an organization's likelihood, severity, and risk matrices to make sure that all the analyses are carried out based on those corporate risk requirements. And all of that captured knowledge then fits into this automatically generated report and makes it much easier to communicate the findings. And so when we think about what all of this means in terms of the bottom line and looking at what are the benefits of using exSlLentia Cyber, we can point to a couple key ones, some of which we've already touched on. So the first is really getting that knowledge capture, making sure that that really deep cybersecurity knowledge within an organization, that it doesn't just stay within kind of the heads of a few key people, that it's easier to disseminate and to actually make it more accessible for parts of the organization that need to look at the risk assessment. Another benefit is it keeps you from having to use some sort of treasure map based approach to sort through all of the documents and document management systems to find where the results for the risk assessment are kept. This makes it much easier to find during revalidation and can really be an effective way of having that detailed record. It's also helpful if you do use exSlLentia for process hazard analysis or any other safety risk assessments. You can actually keep your full risk register in one file. And so for that site, you would have one place to go that has all of the risk-based information. What we've seen is now that the tool is in place, it really does cut down in the amount of time required to do a project. So once that initial configuration is defined, you've really then got an effective framework to go through and complete any subsequent assessments or subsequent facilities. Just being able to even link within the same project is a huge time savings over doing the same type of work in Excel. And that is something that really can help the assessments move more quickly. Another thing that we've seen is with the reporting, it makes it a lot easier to kind of broadcast the results and have them in an easily communicatable format. The last thing you want to do is spend all of this time going through the detailed analysis, coming up with these great results and recommendations, and then try to share them with the organization or try to get buy-in from across the organization and just not have people necessarily understand what was done during the analysis, or have them not able to really understand or grapple what the risk rankings mean or try to understand the format. So having the reports really makes this communication a lot easier and can make it much more effective for subsequent reviews. And really the bottom line is all of this gained efficiency, all of this time that's gotten back really correlates to cost savings on these assessment activities. And when you think about the lifecycle approach, it's not just saving time, time and money by doing it more effectively and more efficiently, but it's also the adoption of the lifecycle increases the cybersecurity preparedness of a site, and it helps to reduce the probability that a cyber attack is going to be one of those that results in a business consequence. And so that's another way where it really does have a strong financial basis. And so by using the tool for all of these different pieces and parts, you really can then define what the benchmark is for that system in terms of risk, and all subsequent risk assessments can be done based off of that to determine whether the risk is getting higher or lower. So in summary, today we looked at kind of the NotPetya example of a recent cyber attack. We talked about how the cybersecurity lifecycle is really a critical way for industrial control systems to improve their security readiness. And then we looked at how the exSLentia cyber tool could be used to fit into that lifecycle and some of the benefits of the tool-based approach. So that's really our main content for the webinar today. What I do want to do quickly before jumping to questions, I did see a couple pop up, is just highlight some of our exciting events upcoming for cybersecurity. So we do offer a number of cybersecurity courses, and we've got some dates upcoming. So we've got our CS204 coming in February out of our Sellersville office, and this is really everything you need to know about IEC 62443 for integrators and solution providers. We have our CS102 course, which is the cybersecurity lifecycle for end users and asset owners. So if you found the discussion of the cybersecurity lifecycle interesting in this webinar, this would then be the course that really does a full coverage of that lifecycle. And so I'll actually be teaching that upcoming in Houston, as well as some courses in Boston out of our Sellersville office and also on the West Coast. In addition to those two courses, we do have CS201, which is the cybersecurity software development. And so this really tackles IEC 62443 for manufacturers. In addition to our live courses, if you aren't able to necessarily get the time away for them, or they're not necessarily offered in an area near you, we do also offer online self-paced training. And we are very excited to announce a new recording for the CS102 course that now has our first online offering of our cybersecurity courses. And so that is a really great option if you are interested in learning more. If you are interested in in-person training but don't see any times or locations near you, don't be afraid to reach out and send an email. We're always open to trying training in new locations. And so we'll definitely work with you to try to find a training plan that works for you. In addition to our training courses, next week in the UK, we're doing a Cyber Week. And so that includes some training as well as a complimentary seminar. So anyone over in that neck of the woods who's interested should definitely check it out. It's a great event that can really kind of help start to get an idea of the cybersecurity risk for industrial control systems. The slides will go out that have really the best places to track exida to get updates on other webinars like this or other material that we put out. So now I'm going to take some time to answer the questions. My email is up there on the screen, so if you do have any other questions that you would like to ask and don't have time to today, please feel free to email me. I'm always happy to get those, and we'll take time to answer. Okay, so let's see. So our first question is about implementing firewalls and VPNs for industrial control system designed and installed prior to the year 2000. So the answer to that first part of the question is yes, absolutely. And so it is oftentimes for some of those systems that are, say, a little bit older, that it's really important to have that effective network segmentation because they can't necessarily be updated to the most recent patches. And so the more oftentimes they're even more exposed. But if we think about the implementation of the firewalls and the VPNs, just think about, first off, taking the general zone and conduit approach. So reviewing the network architecture and seeing what devices have logical connections that are required and similar security requirements. And then really just boundary devices between any of those zones can be implemented. The key is finding technology that will work. So you want to work with the equipment vendor to understand kind of what sort of communication capabilities there are. But typically most modern firewalls should be able to work on that. It's just having the proper communication and developing the specific firewall rules for that system that have the right protocols. But so that is absolutely something I would recommend for any control system, regardless of when it's installed. The next question is, does CyberFacts contain databases to assist the users, facilitators run the workshops? So yes, so every CyberFacts worksheet or anyone who purchases the tool does get the default database that comes with it. This has some information on initial threat likelihoods that we would like to consider. It's got some guidance for threat levels as well as predefined threat vectors to look at and some countermeasures that can be considered. So there is a generic default that comes with that, but as well as some tutorials and stuff that can help to use the tool. What we've seen some clients do and has worked really well for them is, in addition to buying the tool, they'll also get some help developing the cybersecurity management system. And so we can work with them to actually define a custom library that has kind of all of the industry knowledge going into it, as well as the specific thing that organization looks at. And so once that's completed, then you really have a robust library that has all of the requirements that that organization wants to look at. And while it's not, we definitely want to say that there's no replacement for having knowledgeable facilitators and the right people in the room, but it can certainly make the job a lot easier and give more consistent results. Okay, so this question is, can the Cyber PHA tool work with other PHA software tools if a different product is used for the main PHAs? And so you certainly aren't restricted from using the Cyber PHA tool if another software tool is used. Depending on the license you look, there are importers that can directly import PHAs done in other software into exSILentia, into the facts module to kind of get it into the same tool. Or what you can do is really just use it as a reference when defining the consequence severity. And so things like the risk matrix, you'll have to redefine in exSILentia. But if you line up the Cyber PHA risk matrix and have that as a reference for documenting the consequence severity, we've done some example projects like that. And typically just being able to match those two things not only leads to consistent results, but also makes it a lot quicker to go through and do the analysis. So it's certainly an option for people who don't use exSILentia as their normal PHA software tool. Okay, so the last question that I'm seeing here is, in terms of revalidation requirements for security risk assessments, what's typically seen in the industry? Are there formal requirements? And so if we think about in the US OSHA PSM requirements for the main PHA, that typically has to be revalidated at least every 5 years. And for a functional safety assessment, that's typically a pretty good guideline unless there are major changes going on in the system, because for each of those major modifications, that's then another opportunity or another area where that really triggers the risk assessment revalidation. For secure cybersecurity risk, because the threat vectors are changing so frequently, because the technology is continuing to evolve, we typically like to recommend at least some type of yearly review, not necessarily a full revalidation of the assessment, but more going through and saying, are the assumptions that were made during the risk assessment still valid? What sort of additional information do we have to kind of, better define this? So typically looking at things like that on a yearly basis, and then maybe doing that full revalidation every 5 years tends to be pretty effective. All right, so that is the last question I see coming in. If you do have any other questions that you think of later, please don't hesitate to email me. Thank you very much for your time on the webinar today, and please enjoy the rest of your day. Take care. Bye.